All right, so this lesson is on parallel and perpendicular lines. Parallel and perpendicular lines. So here are the properties you need to know about parallel and perpendicular lines. So for parallel lines, they have the same slope and different y-intercepts. So parallel, hopefully you know that parallel lines look like this. And remember that slope really is a measurement of how steep a line is. So parallel lines have the same steepness, so it makes sense that they have the same slope. But they're not going to cross the y-axis at the same point, right? So if I draw an x and a y-axis here, you can see that it's cross the y-axis at different points. So they have different y-intercepts, but they have the same slope. All right, now what about perpendicular lines? So perpendicular lines, if you don't know, perpendicular lines would look like this. So they cross at a right angle. Those are perpendicular lines. So those clearly don't have the same slope. But here's the deal. The product of their slopes is -1. So if I take slope 1, so let's call this slope 1, and let's call this one slope 2, and I multiply those together, slope 1 times slope 2, you would get -1. Well, what the heck does that mean? Here's what that means, and this is why this is important. That means that the slopes are opposite reciprocals of each other. So if one of them has a slope of 2/3, the other one has a slope of -3/2. Reciprocal means you take a fraction and you flip it over. So the negative or opposite reciprocal of 2/3 is -3/2. And that's really the property you're going to use more than the fact that the product of their slopes is -1. Although it is. So just to show you, if I take 2/3, the slope of this one, times -3/2, the slope of the other line, you would get -6/6, which simplifies to -1. So the product of their slopes is -1. But more importantly, their slopes are opposite reciprocals of each other. If one's positive, the other one's got to be negative, right? Because they lean in opposite directions. And I forgot to point out up here, these two lines both have a slope of 2. So these are in slope-intercept form. Hopefully you've learned about slope-intercept form. If not, I'll put a link up in the upper right-hand corner up here. But they have the same slope, but different y-intercepts. The B represents the y-intercept. So we can use this to our advantage, and I'm going to show you how we're going to use this. All right, so this is just a visual example of that. So the line in red here is y equals 2x. The line in blue is y equals -1/2 x minus 2. So if you look at the slope here, the slope of this one is 2, and the slope of this one is -1/2. And I forgot to write 2 up there. And those are negative reciprocals of each other. So remember, 2 is the same thing as 2/1. Flip that over and make it an opposite, and you'd get -1/2. So those two lines are perpendicular. Now, if you were just looking at this, you can't know for sure that this 90-degree angle right here, because you can't just tell with your eyes. Sure, it looks like it, but the way you can know for sure is look at the slopes and see if they're opposite reciprocals of each other, which they are. Or you can multiply them together and see if you get -1. So 2 times -1/2 is -1. All right, now here's two lines that are parallel, and the way we know they're parallel is that they have the same slope. This one has a slope of 1, and this one has a slope of 1. And they have different y-intercepts. So this one crosses the axis at 4, and this one crosses the y-axis at -2. Okay? So again, here's the takeaway. Perpendicular lines, their slopes are opposite reciprocals of each other. Parallel lines, their slopes are the same. Okay, so how can we use that? Let's see. So you have a line that passes through this point, and is parallel to the graph of this equation, of this line. It's parallel. That means it's got the same slope as this. Write the equation of the line in slope-intercept form. So they're wanting us to write the equation of a line that's parallel to this line and goes through this point 12.5. So what's the information that we have? First off, we know the slope of this new line. The slope is going to be 2/3. It's going to be the same as this one because it's parallel to it. And then we also know that it goes through the point 12.5. This is an x value, this is a y value. So if we know a slope and a point, what form should we use to write the equation? Yes, they're asking for it in slope-intercept form, but we don't know the intercepts, so we can't do that yet. So a point and a slope, your brain should be screaming point-slope form. Y minus y1 equals m times x minus x1. So this is the form you want to use if you have a point, x1, y1, and a slope. So we're just going to plug those in to the point, into the formula here. All right, so y minus 5. Remember, if this was a -5, this would be +5, equals the slope, which is 2/3, times x minus 12. So I just plugged in this point for x1, y1, and I plugged in the slope. Now they want this in slope-intercept form, so we've got to manipulate this. So remember, slope-intercept form is y equals mx plus b. So we need to solve this equation for y. So to do that, the first thing I'm going to do is distribute to get rid of these parentheses here. So I'm going to distribute 2/3 in here. And that's going to give me y minus 5 equals 2/3 x minus 2/3 times 12. I'm going to do it over here on the side. Remember, you can cross simplify when you're multiplying fractions. So that comes out to 8/1 or 8. So 2/3 times 12 is 8. All right, so I'm halfway there. Now I need to get rid of this minus 5, and I do that by adding 5 to both sides. I'm adding 5 to the 8 because those are like terms. What I have is y equals 2/3 x minus 3. So this is the equation of a line that's parallel to this one and goes through the point 12.5. And notice these two lines have the same slope and different y-intercepts. This has a y-intercept of -1. This has a y-intercept of -3. All right, let's look at another one of those. Same thing here. They're giving us a point and they're giving us the equation of a line, but this time they want it to be perpendicular. Okay, so perpendicular lines, their slopes are not the same, they're opposite reciprocals of each other. So if the slope of this one is 1/3, the slope of the line perpendicular to it is -3. So 1/3, flip it over, you get 3/1, make it negative, so it's opposite reciprocals, and that just simplifies to -3. So the slope is -3, and it goes through the point 2, 4. This is my x value, this is my y value. So again, I have a point and I have a slope, so I'm going to use point-slope form. That's a triple y. I'm going to rewrite that. So y minus y1 equals m times x minus x1. So I just plug these in. So y minus the y1 value is 4 equals m, which is -3 times x minus 2. Write the equation of line in slope-intercept form. So they want us to solve this for y to put it in slope-intercept form. So same thing as before, I'm going to distribute here. So now I have y minus 4 equals negative 3x plus 6. Negative coming in with the minus makes plus 6 there. Add 4 to both sides. And I get y equals negative 3x plus 10. All right. I got one more slide for you here. Are the graphs of each pair of lines parallel, perpendicular, or neither? So again, the key to telling if they're parallel or perpendicular is the slopes. So the slopes have to be equal if they're parallel. If they're perpendicular, they're opposite reciprocals of each other. So the slope of this line here is 4/5. I don't know what the slope of this one is. So I need to put it in slope-intercept form so that I can find out what the slope is. So how do I put that in intercept form? I'll solve it for y. So just divide by 4. And I have to divide everything by 4 here. So then I get y equals negative 5 fourths x plus 3. So the slope of this one is negative 5 fourths. So 4/5, negative 5 fourths, those are opposite reciprocals of each other. So that means that these lines are perpendicular. All right, let's look at this next one. So again, this one's in slope-intercept form, so the slope is 3/4. I need to solve this one for y, so I need to put it in slope-intercept form. So the first thing I do is subtract 4x from both sides, get the x on the other side. So that cancels out. I have negative 3y equals 9 minus 4x. Divide both sides by negative 3. Divide everything by negative 3. I get y equals 9 divided by negative 3 is negative 3. This minus and the negative will make a plus. And then I'm going to rewrite this because slope-intercept form is y equals mx plus b, so I'm going to swap these around. So I'm going to write this as y equals 4/3 x minus 3. That negative sign belongs to the 3, so that's why that's minus 3. This is a positive 4/3 x. And so the slope of this one is 4/3. So 3/4 and 4/3 are reciprocals of each other, but they are not opposite reciprocals. Both of these lines are leaning to the right. They're both a positive slope. So the answer to this one is neither. They're not perpendicular or parallel. All right, I got one more for you. So the slope of this one is negative 1/6. It's in slope-intercept form. This one, I need to solve it for y. Let's divide by 6 to get the y by itself. So I end up with y equals, there's a 1 in front of the x that's not written. So this is 1/6 with a negative. So I'm going to write it like this, plus 1. And so the slope of this one is negative 1/6. Slope of this one's negative 1/6. Equal slopes tells me that these are parallel. All right, so I hope that that was helpful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.